In this video, we are going to talk about section 5.6, which is the law of cosines. The first thing we need to know is when do we use the law of cosines, and you can see at the top of your paper, we're going to use it when we are given side, 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 so all three sides, or when we're given side, angle, side. And side, angle, side is when we have two sides and then the angle between them, okay? Those are the two times when you'll choose to use the law of cosines instead of the law of sines. Now, the law of cosines is any triangle with standard labeling where the angle is across from the side length. So it does take some memorization. Now, it seems like three different things, but I will talk about how I kind of remember it. First thing I'll have you do is change your angles, because if you have a squared equals b squared plus c squared minus 2bc times cosine, we're going to change the alpha to an a. Okay? If it's b squared, then it's equal to a squared plus c squared minus 2ac cosine. Just call that angle b. And then c squared equals a squared plus b squared minus 2ab cosine c. And again, you might think that, well, I have to memorize three things now. But really, the way I think about it, is the thing that you're taking the cosine of is the same as the side across from it. The side across from it's by itself. And so that's what determines which one you want to use. So if I want to find side length a, I would need to use or cosine of angle A. Okay, so we kind of work on the pieces we're given. But again, you're given side, angle, side, or all three sides. If you're given all three sides, you'd use whichever one angle you're trying to find. So those two pieces go together, and then I know that I square and add the other two sides, and then subtract 2 times those two sides. So once you've used it a few times, it gets kind of repetitive. You can see the pattern. Here's an example of where I'm given a side, angle between them, and a side. So this is an example of SAS. Then in my mind, I know I need to use the law of cosines. Again, it obviously comes up in the law of cosines section, but because I am going to be taking a test where problems will be mixed together, I need to make sure I identify when I need to use it. Okay, now in this case, because they give me angle A, then I'm going to use the top version, which is a squared equals b squared plus c squared minus 2bc cosine of that angle A. Then I substitute what I know. A squared equals, so this is angle B, so this is side B, which would be 4 squared, plus this is angle C, so this is side C, 5 squared minus 2 times 4 times 5 times cosine of angle A, which is 45 degrees. And make sure your calculator is in degree mode. And then we will just both sides. I can type that in one shot. And so I get a. Having said that, it's asking me to study the triangle. So finding side length A was the thing that I would use the law of cosines for. When I use this, I can now use the law of cosines again, because I do have side, side, side to find one of my angles. Or you could use the law of cosines. If you use the law of sines, I mean, then the order matters. So we haven't talked about the ambiguous case yet, but you could in the end use the law of sines, but you have to be very careful. So today, since we haven't done the ambiguous case, we're just going to use the law of cosines. If I want to find an LB next, then I would use the b squared minus or equals a squared plus c squared minus 2ac cosine of b. Okay, so I'd have, I know my b is 4, so I'd have to do 4 squared equals a squared, which is 3.4 squared, plus c squared, which is 5 squared, minus 2 times 3.4 times 5 cosine b. We actually have to be pretty good at our math. I'm going to subtract 3.4 squared and subtract 5 squared. I usually write it all out like this, but I have 4 squared minus 3.4 squared minus 5 squared equals negative 2 times 3.4 times 5 cosine b. divide by all these things. 2, 3.4 times 5. Divide by -2 times 3.4 times 5. And then in the end, if I want to solve for beta, I would have to do b equals cosine inverse of that fraction. 4 squared minus 3.4 squared minus 5 squared, all over -2 times 3.4 times 5. When I type that all into my calculator, I have my calculator in degrees, I got 52.8 degrees. Then the last angle, angle C, is easier to find because I just do 180 minus 43 minus 52.8. So angle C is 84.2 degrees. Okay. So that's law of cosines. Now, the next one I want you to try on your own. A triangle truss is shown in the figure. Find angle theta. So this one you don't have to solve the triangle. You just need to find angle theta. Okay? So pause the video, try it yourself, and then move on. Doesn't really matter, but the important thing is that I need to use the first version, where I would use a squared equals b squared plus c squared minus 2c cosine a. That's really the most important thing, or just knowing that the side across from the angle is over here. So 13 squared, doesn't matter the other two, 16 squared plus 20 squared minus 2 times 16 times 20 times cosine. And again, this is that situation where I would subtract 16 squared and 20 squared. The good news is it's algebra, but there are 13 squared minus 16 squared minus 20 squared equals -2 times 16 times 20 cosine. You don't have to show all this work. If you get to the point where you practiced enough times and you can just kind of see how they move in your head, that would be fine. And so then I would get to the point where I do a equals cosine inverse of 13 squared minus 16 squared minus 20 squared all over -2 times 16 times 20. Typed it in my calculator and I got 8 equals 40.5. So this is 40.5 degrees. And so that is the only thing they were trying to find. Okay, so that actually is the information you need to get through assignment number 2. It's just practicing law of cosines. It's in 5.6. 494. Numbers 18. Oh, no, sorry. 4, 6, 11, and 30. Thanks.